Hello students, straight back again. Today we get notes for section 3.1, solids, liquids, and gases. First key question we have, how can shape and volume be used to classify materials? And materials can be classified as solids, liquids, and gases based on whether their shapes and volumes are definite or variable. And what do four objects have in common? A pencil, a quarter, a book, or cafeteria tray. They'll have a recognizable shape. They'll take up a certain amount of space. These materials are all in the solid state. And we got a definition for solid. Solid is a state of matter in which materials have a definite shape and a definite volume. With definite shape and definite volume, we just mean they're not going to change without some external force acting on them. The reason they have these is because their atoms are packed close together in an orderly arrangement. And almost all solids have some type of orderly arrangement of particles at the atomic level. There are some that don't have an orderly arrangement. We call these amorphous solids. And they're almost like a very, very thick liquid. And we got liquids. Shape of a liquid will change as you move it from one container to another. A liquid will always have the same shape of its container. It can be poured from one container to another. So when we talk about liquids, we say they have a definite volume, but not a definite shape. As we pour this liquid from one container to another, volume of it does not change, just the shape. Mercury, a liquid. Mercury always have the same shape of its container. So atoms in a liquid are close together, but the arrangement is more random than the arrangement of atoms in a solid. Gases. Gas has neither a definite shape nor a definite volume. Gas will take the shape and volume of its container. Balloons illustrated here, filled with helium, colorless gas, less dense than air. Shape of the helium, it's the shape of the balloon itself. The volume of helium is the volume of the balloon. So always shape and volume of its container for a gas. Atoms in a gas are not arranged in a regular pattern, random locations throughout the container. And because the space between helium atoms, a large amount of helium or any other gas can be compressed into a metal cylinder. When it flows out of the cylinder, the helium atoms or gas atoms will spread out. So, helium atoms or any other gas contained in a pressurized cylinder can spread out and fill much greater volume than the volume of the cylinder. We have a fourth state of matter called the plasma, and it's estimated about 99% of all the matter in the universe exists as plasma. This is a state of matter found in stars and the sun. Happens at very high temperatures. We have plasma, very high temperatures, very highly energized gas. And if we go down to very low temperatures, near negative 273 degrees Celsius, absolute zero, groups of atoms start to behave as though they were a single particle, and this is called a Bose-Einstein condensate, or BEC. On Earth, we don't see these much, but out in space, in the universe, we do. So the sun and stars, Bose-Einstein condensate out a long ways out in space, matter appears to be existing as this. On Earth, we do see some things of get back where I want to be. There we go. Plasma. No. Some examples of plasma we see on the Earth would be fire, lightning, and fluorescent lights. These are all generated due to plasma. Then we have a thing we call the kinetic theory of matter. Kinetic theory of matter says that all particles of matter are in constant motion. Kinetic energy an object has due to its motion. Key question, how can kinetic theory and forces of attraction be used to explain behavior of solids, liquids, and gases? A ball thrown at 137 kilometers per hour has more kinetic energy than a ball thrown at 125 kilometers per hour. According to the kinetic theory of matter, particles inside the solid baseball are also moving. Kinetic theory was developed to help explain the behavior of gases, but it also helps explain the behavior of liquids and solids. Key question again. So if you think of billiard balls, that'd be like a little bit like the motion of particles in a gas. Cue ball strikes a ball and moves in a straight line until it strikes the side of the table or another ball. When a moving ball strikes a ball at rest, the first ball slows down, the second ball begins to move, and kinetic energy is transferred to these collisions. Illustration of what we just talked about. The difference between billiard balls and the particles in gas. Particles in a gas are never at rest. At room temperature, average speed of particles in a gas is going to be somewhere around 1,600 kilometers per hour. And note it said average, meaning not all particles are moving at the same speed. Some particles are going to go faster, some are going to be going a little slower. But they're going to keep moving until they strike something. And then they'll change direction, energy transferred from one particle gas to another. Illustration showing some helium atoms in a container of gas. So each atom is going to move in a straight line till it collides with the other atom or the container. During the collision, one might lose energy, others going to gain energy, but the total kinetic energy is going to remain the same. Another key point, forces of attraction among all particles in all matter. In a gas, particles are far apart, moving fast, so the forces of attraction are too weak to have an effect. So in gases, we can ignore these forces of attraction. In solids and liquids, we can't. the key point. Constant motion of the particles in a gas. Allow gas to fill a container of any shape or size. Then the key ideas between the kinetic theory explaining the properties of a gas. Properties of gas are in constant random motion. Motion of one particle is unaffected by the motion of others unless they collide. And the forces of attraction in a gas can be ignored. Back to our key question, how does this help explain our properties? Now we're going to use it to explain a little about the properties of liquids. So, average speed of mercury atoms, or atoms in a liquid, is much slower than those in a gas. They're much more closely packed together, and the attractions between the particles do affect the movement of the particles. You can think of a liquid as an illustration like this group of people. They're always going to be close together, but they can move around from one place to another. Illustration like this in a gas would be a group of people like this, but spread out in a big gymnasium and just running as fast as they can until they collide with something. Here, motion much more restricted. So a liquid, key point, liquid takes the shape of its container. Because particles in a liquid can flow to new locations, the volume remains constant because the forces of attraction keep the particles together. So, in a liquid, kind of like a tug of war between the constant motion of the particles and the attraction amongst the particles. Because the forces of attraction limit the motion of the particles in a liquid, the particles cannot spread out and fill a container. And then we get to use kinetic theory to explain about solids. Solids have a definite volume and shape because the particles in a solid vibrate around fixed locations. So in a solid, particles are not moving much. They do not have near as much kinetic energy. So the forces of attraction hold them pretty rigidly into place. Vibration, a repetitive back and forth motion. Strong attractions restrict their motion and keep them in place. Now, the attractions between the particles in solid and liquid gas are not much different. Big difference is the amount of energy they have, amount of kinetic energy they have. At higher temperatures, atoms are going to have much more kinetic energy, so solids occur at lower temperatures, not as much kinetic energy, so the forces of attraction hold them together. Now, this might be like people sitting in a seat at a theater. If everybody stays in their seat, they can move around a little bit, but they always stay in essentially the same location. Materials are classified as solid, liquids, and gases based on their shape and volume. Which of the following statements describes gases based on kinetic theory? The forces of attraction between the particles can be ignored under certain conditions or under ordinary conditions. The other ones would all be false. Most of the matter in the universe exists as plasma. Remember, that's in the stars and the sun. So that's all we have for section 3.1. This is Strike. Till next time.